The human brain is an enigma, a universe unto itself. In a 2023 article titled "The Staggering Complexity of the Human Brain," it is stated, the brain contains around 86 billion neurons, 85 billion other cells, and over 100 trillion connections. And the function of the brain is even more complex than its structure, with consciousness itself as the greatest unsolved mystery. All of this is fueled by an astonishingly small amount of energy. Imagine a machine more complex than any supercomputer, yet powered by a mere 20 watts, about the same as a dim light bulb. That's the human brain, an organ of unparalleled complexity and efficiency. The brain's remarkable energy efficiency has baffled scientists for decades. How can such a complex organ function on such a limited energy budget? This question challenges our understanding of both biology and physics, hinting at an efficiency far beyond our current technological grasp. It begs us to consider the elegance of our brain's design, a design that surpasses even our most advanced technological marvels. Consider the energy demands of our most sophisticated computers. Supercomputers, capable of performing quadrillions of calculations per second, often require megawatts of power, which is enough power to power a small city. These machines, despite their immense processing power, still pale in comparison to the human brain's versatility and efficiency. For instance, a November 2023 article titled "Mind in the Machine" from Stanford Medicine stated, "To write your girlfriend a poem, ChatGPT-4, an artificial intelligence system, requires orders of magnitude more energy than your brain does. Training complex AI models, such as those used in natural language processing or image recognition, requires enormous amounts of computational power and energy." For instance, in a 2019 article titled "The Brain Exceeds the Most Powerful Computers in Efficiency," it is stated, AlphaGo Zero would need to be 100 million times more efficient in order for AI to exceed human performance on an equivalent task. Yet, the brain effortlessly navigates complex social interactions, learns new languages, and even writes poetry, all while consuming a fraction of the energy that supercomputers do. The brain's energy efficiency is remarkable. Let's consider the energy consumption of a single neuron. A 2019 article stated that a single neuron contains about 50 billion proteins. Yet a neuron, despite its staggering complexity, consumes a minuscule amount of power, about 10 to the power of -16 watts. This is orders of magnitude less than the power consumption of a single transistor in a modern computer chip. Moreover, the brain's energy efficiency extends beyond individual neurons. The brain's energy efficiency stems from its unique architecture, which differs significantly from the binary logic of computers. Unlike computers, which process information sequentially, the brain operates in a massively parallel fashion. Billions of neurons fire simultaneously, forming intricate networks of interconnected activity. This parallel processing allows the brain to perform complex computations with remarkable speed and efficiency, all while consuming a fraction of the energy required by traditional computers. The stark contrast between the brain's energy efficiency and the energy demands of modern computers is also evident in the fact that computers only consume energy when they are computing tasks, whereas, on the other hand, the brain remains remarkably constant in its energy demand despite widely varying mental and motoric tasks. As the 2002 article titled "Appraising the Brain's Energy Budget" states, the metabolism of the brain is remarkably constant despite widely varying mental and motoric activity. Likewise, in an article titled "The Effect of Mental Arithmetic on Cerebral Circulation and Metabolism," it was found that cerebral oxygen consumption is unaltered during mental arithmetic. Darwinian materialists simply have no realistic clue why the brain should be remarkably constant in its metabolic activity, despite widely varying mental and motoric activity. Darwinian materialists hold that the immaterial mind is somehow an emergent property of the material brain. As Pierre Cabanis notoriously claimed in the 18th century, the brain secretes thought as the liver secretes bile. Yet, to state the obvious, such an optimal constraint on the brain's metabolic activity, despite widely varying mental and motoric tasks, is completely antithetical to the entire notion that the brain secretes thought as the liver secretes bile. As Norbert Wiener once stated, the mechanical brain does not secrete thought as the liver does bile, as the earlier materialists claimed, nor does it put it out in the form of energy, as the muscle puts out its activity. Information is information, not matter or energy. No materialism which does not admit this can survive at the present day. While Darwinists have no realistic clue, the intelligent design advocate has a ready explanation for why the brain's metabolism is as constant as it is. Namely, the most parsimonious explanation for such constant metabolic activity of the brain, despite widely varying activities, is that the material brain was designed, first and foremost, to house the immaterial mind and to give the immaterial mind the most favorable metabolic environment at all times. In short, the Darwinist is, once again, found to be wanting for a coherent explanation, all the while steadfastly refusing to accept the answer that is sitting right in front of him. The human brain is an engineering marvel and is an enigma that continues to challenge the brightest minds as well as the analytical abilities of our most advanced computers. In a 2019 article titled "Protein Supply in Long Nerves: How Do Neurons Do It?" it is stated that a single neuron contains around 50 billion proteins. In a 2023 article titled "The Staggering Complexity of the Human Brain," it is stated the brain contains around 86 billion neurons, 85 billion other cells, and over 100 trillion connections. Moreover, in a 2012 article titled "Complexity Break Defies Evolution," it is stated, consider a neuronal synapse. The presynaptic terminal has an estimated 1,000 distinct proteins. Fully analyzing their possible interactions would take about 2,000 years. Or consider the task of fully characterizing the visual cortex of the mouse, about 2 million neurons. Under the extreme assumption that the neurons in these systems can all interact with each other, analyzing the various combinations will take about 10 million years, even though it is assumed that the underlying technology speeds up by an order of magnitude each year. As David Berlinski once stated, applying Darwinian principles to problems of this level of complexity is like putting a band-aid on a wound caused by an atomic weapon. It's just not going to work. So again, to repeat, the human brain is an engineering marvel and is an enigma that continues to challenge the brightest minds and the analytical abilities of our most advanced computers. So what about consciousness? This elusive state of awareness remains one of the greatest mysteries of science and philosophy. How does a collection of biological processes translate into unique subjective conscious experience? The experience of being alive, of feeling, thinking, and existing. As enigmatic as the complexity of the brain is turning out to be, consciousness is arguably even more enigmatic than the brain is. As brain surgeon Michael Egnor succinctly stated, it's sobering to note that neuroscience has utterly failed to explain how the brain and mind relate. It is as if cosmology had failed to tell us anything meaningful about the universe, or medical science failed to tell us anything about health and disease, or geology failed to tell us anything about rocks. Neuroscience has told us nothing about how the brain gives rise to the mind, the hard problem of consciousness. After 2 centuries of neuroscience and a vast trove of data, remains utterly unsolved. As we delve deeper into the neuroscience of the brain, each discovery brings us closer to understanding, yet it also opens up more questions than it answers. How could such unfathomable complexity arise? How could the immaterial mind possibly relate to the material brain? Despite these profound unanswered questions, profound questions that go to the heart of our very existence, one thing is certain: Darwinian explanations are at a complete loss to answer these questions. As J. Homnick once bluntly put it, once you allow the intellect to consider that an elaborate organism with trillions of microscopic interactive components can be an accident, you have essentially lost your mind.